Hey class, last video for part one of our helpful videos. Again, talking about an object on the inclined plane, and it's going to be moving down. So here we have a question where we want to find acceleration. So it's going to say find acceleration. Find acceleration. There's your question. And this is actually question one. I don't know if it actually says question one, but it's the big question at the very top of the worksheet that I put in the file folder for this week. So I'm going to answer this exactly one from start to finish. So here we go. We have a mass of 25 degrees or 25 kilograms. We have a coefficient of friction of 0.32, and we have an angle of 20 degrees. So there's our setup, and we have to find acceleration. So first thing we want to do is find force of gravity, which is this here, force of gravity. For that we go 25 times 9.8, our usual. And we get force of gravity here equals 245 newtons. Okay, so 245 newtons. All right. From the last video, you'll know that we have to break this apart into two different sections. We have to break it apart into our force normal, which is this direction. Okay, and that's exactly the same as this one. This is our force normal. And as well, we have to find our force parallel, which is this direction. Okay, which is the same as the box moving in that direction. All right, so that's what we're going to break force gravity into because it's at an angle. So let's find force normal first. I've left the little formulas up here from last little video. Force normal is going to be cos of 20 degrees and then times our force of gravity, times 245. So when I go cos of 20 times 245, I get an answer of 230.2. 230.2 newtons. So the board is now pushing back with 230.2 newtons of force on this actual thing to keep it up. Because again, force normal is going to have to do less and less work the higher and higher you go. Because if you think about it at 90 degrees, the board does not have to hold this thing up. So it's going to do less and less work compared to gravity as you go up. All right, well now it's also giving some extra force to the sliding component. It's going to give an actual help for the object go down this slope. That's our force parallel. So you can see your parallels here. So force parallel is going to be sine of 20 times 245. And you can kind of see again, we have only 20 degrees, so our parallel is going to be quite a bit smaller than our force normal. If you get higher and higher, like at 80 degrees, your force parallel will be bigger than your force normal. Okay, at 45 degrees, these two things will be exactly the same. But for now, our force parallel is going to be quite a bit smaller. So when I go sine of 20 times 245 newtons, I get something like 83.8. 83.8 newtons. Okay. So that's the force. That's kind of like, it seems like it's a force applied. That's what's actually pulling this box down. This force parallel, 83.8 newtons. Now, if I just had no friction involved in this question whatsoever, that's my actual net force. My net force is 83.8. That's in a question where there's no friction. I'm just going to make this a little bigger because I just look at the screen, looking a little small. Force parallel 83.8. All right, that looks a little better. So again, with no friction, that'd be your force, your net force, and then you can find your acceleration right away. But we are going to have friction here because it gives you a mu. Anytime you're given a mu, there's going to be some kind of friction. So we have to figure that out in this direction. All right, so how do we find force of friction? Again, it's going to be your mu, coefficient of friction, times force normal. It's kind of just barely cut off there, but that same exact formula we've been using for the last 2 weeks for friction. So do we have a mu? Yes, 0.32. Do we have a force normal? Yes, we do. We just found it. It changed because the inclined plane, we just found it. 230.2. 230.2. All right. When I multiply those together, I get an answer of 73.7. 73.7. So friction is slowing us down. Force of friction here. Slowing us down by 73.7. All right. So now we have found all the forces involved. Okay, so there's no more extra forces to find. We just have to figure out actually like what is our net force and then find the acceleration. Well, which two here am I going to be looking for net force? And you're going to have to think of like what direction is this block sliding and what's going to be stopping that force. The block is sliding down the ramp, so that force parallel is what pulls it down, and force of friction is what's slowing it down. So those are the two actual forces you're going to be looking at for this question. Similar to last week, again, where in the sense of like you had your force X when we had the angle force X and force friction. Force parallel has to be bigger than force friction for this thing to move. If this force of friction is bigger than force parallel, your question's done. Your acceleration is 0, and you have no more problems. In this one, though, our force parallel is bigger than force of friction, so it's going to be moving. So let's find a net force. So in these questions, how do you find a net force? Well, force net in these questions equals force parallel minus force of friction. All right, force parallel minus force friction. So we have 83.8 minus 73.7, which gives me an answer of 10.1. That is my force net. Okay? That's what I have to put into my acceleration formula, which goes back to our very simple F equals m times a. And anytime you have a net force, to find the acceleration, you just take your net force and divide it by your mass. So that's what I'm going to do now. To get acceleration, I go 10.1, my net force, divided by a mass, which is what I start with over here, 25. And so I finally get my answer of 0.4 meters per second squared. I'm going to circle that. So that is how we find our acceleration here. So there's the exact first question on your worksheet. This is how to find it. If you guys have any questions, it's Tuesday. This is part 1. The second part of our helpful videos is going to be like, what if I'm pulling in a certain direction? Then what happens? I'm going to put those videos up on Thursday, and then our assignment will come up Friday. It'll be due again. Our assignments are usually due. I'll put it for Monday again, just to give you guys the whole weekend as well as Monday to ask me questions. But again, come into school if you need some help. I'm always here. Just give me a message. That way I can find you in the school, or I make sure I'm in the chem lab for you guys. But hopefully these videos help out. I've attached some other good links. So this will answer your front side of the worksheet, and by Thursday I'll put up the questions that will answer the back side of the worksheet. A full answer key will be out on hopefully Wednesday, latest by Thursday for sure. All right, class, thanks so much. Have a good time.